Morning, ladies and gentlemen. A very warm welcome to day 2 of the Gyan course on Artificial Intelligence and Machine Learning Algorithms, a comprehensive study. Yesterday, we laid a strong foundation by exploring the evolution of algorithms, types of machine learning models, and their wide ranging applications. Today, we continue this journey with another set of insightful lectures by our distinguished speakers. We begin with Professor Anu Gokhale, who will first deliver a lecture on research studies in AI and ML algorithms from 10:30 to 11:30 a.m., followed by her second lecture on AI ML applications in varied areas such as computer networks, software security, biometrics, education, and business from 11:30 a.m. to 12:30 p.m. After the lunch break, we will have two engaging sessions by Professor Gautam Makwana. From 1:30 to 2:30 p.m., he will speak on deep learning fundamentals, and from 2:30 to 3:30 p.m., he will conclude the day with a lecture on the role of LLM and data analytics in AI/ML. We are confident that today's sessions will enrich our understanding even further and provide deeper insights into both the theoretical and applied aspects of AI and ML. Over to you, Professor Anu.
Yeah, thank you. Thank you all. Good morning to everyone of day 2 of our workshop or, course. And this course, of course, is in AI and machine learning algorithms, a comprehensive study presented by me and Dr. Makwana. So like was mentioned earlier, today we are going to talk about studies in AI and ML and followed by applications in various areas. Okay, so I'll be talking about my research that I've done with different teams in computer networks, software safety, biometrics, and so on. Okay, so let's begin with our lecture 5, which is research studies and AI and ML algorithms. As you know, this is our outline. We always begin our day with a 1-minute meditation, preparing ourselves by mind, spirit, power of silence. I'm sure many of you are youth, and I understand that popular among the youth in India. So meditation is the only freedom from stress, tension, and anxiety. That's his quote, Sadhguru. And so let us prepare ourselves. I'm going to start my timer here. So okay, folks, let's begin. Okay. Okay. So we are all ready, right? Okay. So what we'll do is we'll begin with a step-by-step guide to research using ML algorithms. This is the way I conceived this morning. First, I'll talk about how the research study is done, like the mechanics of it. And then in the second part, I'm going to give you examples of what the research that my teams have done. Okay. So this is kind of a guide. How should I or you go about beginning with research in AI ML? Okay. So embarking on a research study, The first, of course, is defining the problem of the study. So, we have to be able to define the problem of the study. Review of literature is extremely important. Determine research methods used to address the problem. So after you define a problem of the study, then what other studies have been done related to that problem of study? Of course, your problem of study is going to be a little different from what has already been done, unless there are some research studies. So, we were talking about embarking on a research study. What's the first thing to do? Of course, define the problem of the study. Review of literature is mainly used for determining the research methods used to address the problem. I was mentioning that it is okay to repeat a research study, is what I was trying to say. Okay, because many times the repetition actually establishes the reliability of the previous study. So if it is a topic of importance, it is okay to repeat, maybe with, okay, so maybe you want to have some variation in it rather than exact replication, but it is okay to replicate a research study, is what I'm trying to say. Okay. And if you were to apply it to another similar problem, then you would have a rationale for why you're doing what you're doing, okay, for the research method. Certainly the databases that were used, because many times the databases, and then at the end of every research article, you will find directions for future research, correct? So read those directions carefully, because that's where the authors say, well, maybe the next step could be this or that or something else, okay? So if you are embarking on a research study, the articles that are related to your topic, try to see what they are saying, what could be done next, because that could give you some guidance. Research methodology, what alternatives are you considering, is basically ask you, why are you doing what you're doing? For every little thing that you do, research methods, especially the research methodology, you have to have a rationale for what it is that you're doing and why you're doing it. Don't just say, oh, this looks cool, so I'm doing it, okay? There is nothing cool about research. It has to be based in science, okay? So make sure there is a scientific reason for doing everything. What data will be needed and why? What was the data needed? What are its limitations? Anytime a study is embarked, one of the things we have to be careful is know in advance what are the limitations of my research study. So that way we are not extrapolating to something that is impossible. Which databases fulfill the requirements? Maybe you will find that the database that is available to you is not comprehensive enough. Can you look for something else? Which data analysis methods or machine learning algorithms are appropriate? So, and we will discuss some algorithms today, and we will talk about their applications. Okay, so we will be doing that. Preparing data for ML is extremely important. The first thing I always tell my students, don't just embark on immediately running the algorithm on the data, because unless data is good, the results mean nothing. Okay, so your results are only going to be as good as the data that you run the algorithms on. So preparing data for machine learning is a critical first step. Okay, almost half of the time of your research should be spent in making sure that you have the right data set. It's like when you cook, if you don't have all the right ingredients, you're not going to come out good, correct? So preparing in advance of all those ingredients that are going to go in, and that's where the data set comes into play, okay? So give a lot of value to the quality of the data, quantity of the data, okay? And then, so both are important. Why prepare? Data may have issues like inconsistencies, missing values, duplicates, outliers, all common happenings in all data sets. So how to prepare? clean the data, remove data discrepancies. There are a lot of cleaning tools. It's not like you have to manually sit and do anything. Okay. So there are a lot of tools that you can utilize, but you may have to utilize more than one tool to actually clean the data set in different ways. Transform the data, convert all data into a consistent format compatible with machine learning algorithms. What happens is when any data is recorded, some data is recorded in one system, other parts are recorded in another system. Those two are not compatible. So when the data set is formed, it is not something that homogeneous that you can actually apply the algorithms to the entire one. Okay, there is a lot of heterogeneity, and that is not good for any ML algorithm because it will not run on the entire data set. So it has to be compatible. That's what we talk about, compatibility in data. So if all the elements in the data set have to be compatible and have to be able to be basically the algorithm has to be able to look at all of them rather than only a select number. Okay, is what I'm trying to say. So the comprehensive means one thing, but comprehensive is not sufficient. They all have to align across on the requirements for the algorithm. So some humor. This is okay, a funny story. Our data random. I ran some tests and it turns out that data is more accurate than our data, So think about it. I mean, there is even randomly created data that, now this is a joke, but what I'm saying is your results are only going to be good as your data set. Okay, remember that. I cannot emphasize enough the value of the data that you run your algorithms on. So preparing data for analytics, we talked about transferring data into a data warehouse, cleaning the data to remove errors and check for consistency of formats. Exploratory data analysis is searching the data using statistical procedures, database queries, visualization, machine learning tools, and more. So machine learning is not the only way to do data analytics. Okay, there is also visualization. Actually, a lot of, if you're in business and industry, more than machine learning, you're going to use visualization techniques. Okay, let me tell you, your boss would love to see graphs because they are not science people, right? Okay, they love to see like pictures rather than words because, like they say, a word says 1,000. A picture says 1,000 words, right? Okay, so same concept. Plus, it's easy to see something graphically and understand what it's saying. So a lot of visualization techniques are very important in analyzing data. So unless you're doing research, which yes, you might need to do, actually science, which is machine learning or something. But if you were to work for a company, try to see how can you project the data so it's more understandable to whoever you're presenting to. That's the whole goal. The goal is not for us to understand what it is that we are doing. The goal is to communicate what it is that we found. So when we communicate something, we have to think about how is the other person going to be able to be receptive to the results that I'm presenting, correct? What is going to be more acceptable to the other person? Visualization techniques are very important. Do not discount statistical procedures because all these data sets, many of them, are not large enough like big data or anything. A reasonable size where statistical procedures are going to be just as effective as machine learning algorithm. You can have actually, it increases the power of the test, as they call it. The power of the test is when you're able to do like data analytics using one method and a second method, and the two correlate. There is correlate or give very similar outcomes, which means you're increasing power of the test. Okay, so try to do something, and that's what we have done in one of our research studies, which I'll talk in the next lecture number 6. But what I'm trying to say is do not shy away from using statistical methods. Okay. after all, machine learning has its base in mathematics and statistics, like we saw yesterday. So data analytic tools, the architecture supports a variety of methods. Statistical analysis used both for summarizing large data sets like average, min, max, etc., and in defining models for prediction. Even statistical models is something that is common. It's not just the machine learning models that we can prepare. Modeling and visual analytics generates interactive visualizations across many data sets with the hope that users will be able to discover interesting relationships. So that's where I was talking about business and industry, folks actually focusing on modeling and visual analytics. A lot of you will be doing modeling, and I'm pretty sure there's a lot of financial models that are run. So, if you are in the finance industry working as a technical person, uh, a lot of done is marketing models are created, and there are many other areas as well. Okay. So remember to actually use your insights to see even insights, not just about what I can gather from data, but what tools can I use. Okay. So don't just get set on, oh, what is the latest and the greatest. Latest and the greatest may be fine, but also look at what might be able to be more effective in what it is that you're doing. Just when to choose one particular algorithm over another. Okay. There is no rule for that. Typically, we have based on the literature, we have studies that have been done that have established that this algorithm worked well for this study, so on and so forth. Okay. Yet we will talk about some of it. For all algorithms, care must be taken to avoid overfitting. That is something we have to be careful. And we will talk here just some quick humor about that. If you torture the data long enough, it will confess. So, even a 9 becoming a 6. So, okay. So let's talk now. Use with clustering and nearest neighbor and their variations. So clustering is, of course, an unsupervised learning algorithm where records together. Yesterday we talked about, we had a whole data set, and then you folks actually generated ideas. Oh, it can be size, shape, color. Remember that? Okay, so that's what we are talking about. Clustering and nearest neighbor, among the first techniques developed for data mining. You'll be surprised that clustering is actually nothing different from how statistics has already had the concept of clustering, right? Primary advantage, these algorithms are robust with respect to dirty data and missing data. That's the biggest advantage, because initially there were very few tools for data cleaning. Okay, so with these algorithms being robust with respect to missing data or dirty data meaning, oh, some are missing, some are faulty, some are spurious, rather than 0.2, somebody records 0.02, whatever. Okay, so that becomes a spurious record, so on and so forth. Applications of clustering algorithms, segmentation in marketing, healthcare, finance, real estate. Anytime you want to segment any population, okay, that is segmentation of the population, grouping people or items based on specific criteria. If you have any examples of your own studies that you are doing and you want to bring something up, feel free. If it is something you have read and you want to bring something up, feel free. Okay. So it can be yeah.
Actually, I have soil database, soil analysis database. Right now, I am considering water analysis in it. Then what we have to do for this?
So water analysis for the soil data.
Water analysis is for the groundwater. And soil analysis, that is a chemical, physical, microbiological enzyme study done in the same region.
Okay.
Okay. Now, if I am making a cluster, that what is the effect of groundwater or for the soil, or what we have to predict in future. So, how it is helpful to me?
Great question. What we will do is, after we have discussed the research studies, we'll take that as an example and open it up to everybody and say, what do you think? How would you do it? Sounds like a good plan, because let me explain everything so everybody is aware of what it is, but a great application.
Okay. Thank you.
Thank you. Purchasing behavior or demographics for product recommendations. So anytime we are, yeah.
Good morning, madam.
Mummy.
Yes. See, the advantage of the clustering method that you have mentioned in this slide is that it is robust with respect to the missing data and the random data. Now, suppose there are more missing data in a given data set, or more random data. So, does it mean that the clustering algorithm will be biased with the random data more than the original data, which is actually accurate in the data set?
That is why I started with saying that your results are only going to be as good as the data that you have. So if your data has all these missing data and issues with, whatever randomly available for certain variables, not available for other, or records, then it's not going to be a very good outcome.
Huh.
So
So in that case, we should not use the clustering.
absolutely, I wouldn't go with a data set that is not good enough. Then just don't do anything. Yeah, unless you do like a smaller study, not actually run an algorithm and say, oh, my data was dirty, but I still ran it. Yeah, I agree. It should not be done. Similar items for online shopping categories. So sometimes you are looking for something and you have recommendations, something similar, right? And this is what clustering is all about. So I'm giving you examples of where clustering can be used. So if you're shopping for clothes, or you're shopping for cleaners, and then it says, oh, this is the cleaner I have, but then, oh, you can buy even this one or that one, or you can group them together. Remember how they sell it in a group? Oh, you can buy the brush, you can buy the cleaner, and you can buy something else. Okay, stuff like that. So that all is part of the clustering, and that is what is the marketing part of it. Okay. So anytime you have an application like that, you know that one of the clustering algorithms would be a good application, would be a good way of addressing that problem. So the problem of the study, data set that you have, now we are talking about methodology or algorithms. Everybody on the same page? Okay. So symptoms or health data for medical diagnosis or treatments and treatments. So it's the same way. It's like clustering or segmentation of the data. Oh, you have all these symptoms. That seems like something to do with the heart problem. It may be overweight. It may be having, like not be able to do as much activity quickly. That is one way of segmentation for data and diagnostics. Based on risk levels for loan approvals, insurance policies, these are all, again, remember that every time what I'm doing is I said segmentation in marketing, healthcare, finance, real estate. So I'm giving examples of what is done in marketing, what is done in healthcare, what is done in finance. That's why you see all these different examples by the sectors that I mentioned in the very first bullet. Okay. So for loan approvals and insurance policies, same way. Clustering by city, right? Whether it's city, urban, how large the city is, which areas in the city, how much are you going to drive? They always ask, are you commuting to work? Are you driving? Yes or no, stuff like that. Assess property values based on features, like that's for real estate. Assess property values based on features like location, size, amenities, because in the same location, exact location. I was in Mumbai recently and my cousin was telling me this one is X value, this one is X, it was 20% higher. Why? Because the other building had a swimming pool, had a gym, so stuff like that. You add just in right next to each other. So the location was the same, the size of the the flat or the apartment was the same. It's just the amenities that made a difference in the price. So, sometimes you were asking yesterday about different factors for feature engineering for real estate and how different, prices can be. It can be a combination of different things. Identify groups within social networks for variety of purposes. This is how basically a lot of research has been going into this particular aspect by companies. Why? Because they want to catch the sentiment. How are people feeling? And that's where how language translates into emotion. Okay, that's what now the research is, most of the latest research is. So identify groups within social networks for a variety of purposes. How do we market to them? Can we change how they think? Right? That is also important. In politics, a lot of if you read some of the papers, the actual, I should say, philosophy of politics, it's all about changing the mindset of the people. And how do you change the mindset of the people? And there are research studies done on that. And even without us knowing that our mindset is being changed, it can be changed. So you'll be surprised. You may want to do some, reading on that. And anomaly detection in finance or network security. So anomaly, and this doesn't always happen. I never get like a ping from this particular server, right? In network security or finance. Somebody just is charging my credit card for $1 at a very remote place. Why would, so then I suddenly get a call from the bank. Were you in that location and did you charge anything? Because they are first going to charge only a small amount to see if it runs and how, how well it is processed, and then they can charge a large amount, correct? Okay, so that's the kind of anomaly. Anomalies doesn't normally happen. That's what anomaly is, okay? Doesn't normally happen. And so we are detecting anomalies. And for that also we need clustering, because this is a cluster. This is a spurious data point outside the cluster. So this becomes an anomaly. And we'll talk about once we look at different, I have a little picture and I'll show you too. Identify unusual or outlier data points. That's the whole point about the anomaly. Fraud detection, credit cards and bank accounts, or cybersecurity. Cybersecurity is the same way. When something unusual incident and then decide which ones we need or like that. So analysis for cybersecurity is very important. If anyone has worked in IT security and if you want to share later your experience, feel free. Okay. So clustering algorithms, let's talk about the algorithms clustering. Creating clusters compete against each other for the records that they contain, that thus ensuring that the clusters overlap as little as possible. So there's a different ways of clustering is what I'm trying to say. Okay, different ways. So one way is where the winner takes all, or every cluster is competing for the data point. Which one? Is this closer to cluster A or cluster B? So on and so forth. So each record in the database falls into one and only one cluster. Okay, that's the basis, that's the assumption, or that's the foundation. Hybrid between neural network and nearest neighbor. So this is a hybrid between those two algorithms. As you can see, that's a spurious point right here at the bottom there. If you can see, that becomes an anomaly. Hey, why did this happen? Right? Okay, what is indicating it. It's something I need to pay attention to now so I can avoid problems for the future. So anytime you're talking about cybersecurity or fraud or anything, the more important thing is the points that fall outside the cluster. Remember that. It's not within the cluster that you're so worried about. You're worried about the points that don't fall with. Yeah.
When we have the anomalies, so when we are analyzing the data, should we remove those anomalies or should go with that kind of thing only for the data?
Initially, we should remove anomaly. Okay, so that's for the when we actually are doing the algorithm, designing the algorithm, we should actually remove anomalies. Okay, so then we have proper clusters. But then in real life, when we are launching the algorithm, then we know that these are the clusters and then we can detect the anomaly. If we keep the anomalies when we are actually designing it, then it's not going to give us a good result.
So, ma'am, you were talking about the cleaning tools as well for removing those anomalies. So, can you suggest some tools? Like, we are from the biology background, so we don't have much idea about this thing. So, can you suggest some tools when we are analyzing?
Sure, I can find which tools would be effective, which are available here, because what's available necessarily in one country may not be available in a different country. So let me check on that.
Thank you.
That's okay. The goal is to maximize the distance between cluster centroids and minimize the distance within a cluster. So make the cluster as tight as possible. That's the whole idea. And also the cluster centroids minimize the distance within clusters. So, these clusters that are next to each other is not what we want. So we want them to be apart as much as possible. Nearest algorithm. So nearest neighbor is supervised, no longer unsupervised, right? We were talking about clustering unsupervised. Now we are talking about nearest neighbor prediction technique. Okay, that is similar. So remember, the same problem we can use supervised or unsupervised is what I'm trying to say. There is nothing that tells us we have to use this or that. In order to predict what the prediction value is for a record, look for records with similar predictor values in the database and use the prediction value from the record that is nearest to the unclassified. This is nothing, it's pretty logical what the statement says, right? If we are trying to predict something, see what the scenario is for a similar one and make unclassified records for whom we need to find the nearest neighbor. Application would be image classification. A lot of research now is going on in medicine about image classification, right? So let's talk about that. For that, we are looking at nearest neighbor. What is very similar to what we are finding? It may be that we are looking for, some unusual activity, tissue, or whatever that may be. Okay, so here we find cluster A, these are all squares. Cluster C, these are all dots. As you can see, cluster B. And then there are this one, as you can see, is closer to cluster C and the dot is closer to B. So it's like there are many times when the clusters are going to be overlapping. Okay. So then it depends on what is the problem of the study. That is where our probabilistic reasoning comes into play. So we have done the function approximation. This is what the math will tell you. But after the math tells you, now we look at, well, in real life, I know that this happens, but there could be, that's how research happens. Oh, this is something that was never detected before, but I am detecting it. So it could be something new that you are finding. Okay. So always leave room for that. Don't just go by what has been, because you may always find something that could be rather than what has been. Okay. So variations of the nearest neighbor, one is for a continuous functions and one is for discrete functions. Discrete is basically, 0, 1, binary, that kind of thing. And continuous, of course, is Euclidean, Manhattan, Minkowski, all of the different distance function. That is for k nearest neighbor, k means. And based on the analysis of variances, you will be surprised that k nearest neighbor is actually an analysis of variance variation. Okay, so it is weighed. And did you know that related articles in Google Scholar, in short, actually they use k weighted means as the algorithm for determining. If you get an article, they'll say, oh, similar articles here, similar articles. That's the k weighted neuro neighbor. So k, so as you can see, cluster 1, cluster 2, cluster 3, these are all the different agents. And K means finds the best centroids, four-dimensional centers of clusters, by alternating between assigning data points to clusters based on the current centroids and then choosing centroids based on the current assignment of data points to cluster. So after you assign, has the centroid moved for that cluster is the question. That is what that second part is asking. The first part is assigning data points to clusters based on the centroids, then choosing centroids based on the current assignment of data points. This is what will be done by the algorithm naturally. You are not doing it, okay? We are not actually doing anything, but we have to know that that is what is being done. And therefore, are the centroids moving? How are then it spins out the results? We have to understand, we have to be the one to interpret the results, right? The results will be given, but how do you interpret them? And that interpretation is very important. A point is considered to be in a particular cluster if it's closer to that cluster centroid than any other centroid, and the centroid is continuously updated to reflect the cluster's mean. So it's not like a cluster is basically a static entity. It's a dynamic entity. Continuously clusters are changing. They are dynamic based on as new data points are added. Okay? Yeah, you have a question?
Madam, in a k-means clustering algorithm, we need to grouping the number of given items based on the value of a k, right? So how do we find the value of a k? Question number one. And question number two is, if we change the value of a k, would now that case centroid can be changed, right? So if we increase the number of a k, then we have the more number of centroid for the given data point. And if we have the more number of the centroid, does it mean that we have the more number of classes?
Okay. Fine. I'm glad you asked that question. If have done, I mean, I'm talking to everybody. If you have done factor analysis in statistics, okay, the way we do is whenever the correlation goes below a certain point, we stop the determining those factors. So that would be there is nothing like, oh, I need 10 clusters from this data set, or I need 5, or I need 2, or, there's nothing like that. You have to determine, the data will just spin out 10 clusters, 4 clusters, whatever, you have to determine where would be the cutoff. As we humans, we have to determine, no, this looks like good. Anything below that is not going to be efficient enough, so I'm going to stop there. Okay, so that would be the way one should do it. And factor analysis, why do I mention? Because there's a lot of research already. If you are doing machine learning, you should have already learned some math and stats, and factor analysis is like primary in different statistical models, analysis of variance, factor analysis. So that idea is very similar to. Yeah.
It's like a elbow method, right? It is like how many number of bits.
Correct. Let's now look at the decision tree algorithms. Decision tree requires labeled data for training. Advantages are used for both classification and regression. Regression is always prediction. And predictors are picked as they decrease the disorder in the data. And that's what the, analysis of variances. You are trying to reduce the variance, right? That's the whole idea of analysis, of multiple analysis, ANOVA. Simplicity and interpretability, visual and structured representation of data-driven decision making, intuitive and easy to explain, making them accessible compared to other machine learning models. So that's what decision tree algorithm. Decision tree is like, it will give you, like, we will look at a picture of a decision tree in a minute, okay? And you will see that it is all very visual. A decision tree is very visual, easy to interpret, okay? So that's why it talks about simplicity and interpretability. Versatility, effective with both numerical and categorical. So doesn't mean it has to just work with numbers. It can be with different, non-numerical data. Use cases, business strategy. I'm sure you have all done SWOT analysis, sometimes strength, weaknesses, opportunities, threats, right? Okay, all of that it's a use case for a decision tree, okay? Project management, risk management, these are all management related ones that are used for decision trees. Because think of it, decisions are made by whom? Administrators, some managers. And for that, then decision tree, that's how the name actually even came. So decision tree algorithm, theoretical example with terminology. Okay, so typically you start with a root node, then you have the branches, yes, no, internal node, then you go to the leaf node. That is all the technicality. Very soon we'll look at a real example. Decision trees are a visual and structured representation of data-driven decisions. Remember, data-driven decisions are, okay, yes or no for this, and then you go to that next, then next, so on and so forth. That's where the data-driven decision-making comes. So, decision tree algorithm, multi-way split, multi-way, because initially we talked about just a binary split, as you can see, yes, no. Okay, that was a binary split. But now we can also do a multi-way split, okay? So travel mode, passenger, transit, or heavy vehicle. And then what are the speeds, slow, so on and so forth. So classify data into slow, normal, and aggressive drivers, interstate, speed limits, so on and so forth. So this is a lot for car insurance companies, right? A car insurance wants to know what type of vehicle are you driving, okay? Where are you driving? What road? What is the speed limit on that road that you typically drive? They are going to, I don't know what they ask here. I'll be honest, I didn't do that research, but I know what they ask in the US. They always ask for, what are you going to commute to work? Where is your work city? What and how many times do you go to work, so on and so forth. So effective with both numerical and categorical or textual data. Here is a binary split example again, and leaf nodes and everything. So weather conditions, sunny, overcast, rainy. Then you say, oh, there is too much wind. So then you can't play tennis, right? If there is too much wind, then the ball goes everywhere. Or even badminton, if you're playing that outside, then, outdoors, then you can't play badminton either, right? So, and if it is raining, you can't play either. So, you look at that sunny, humidity, overcast skies, great, let's play, right? No sun, nothing, we'll play. You understand what I'm saying? So the decision trees are like you make the splits and then take the data, and that's where your decision tree algorithm comes into play. And decision tree can also be used for your medical analysis and stuff like that, okay? Regression or forecasting in education. So predicting student performance on previous performance, used for college admissions. A lot of college admissions at the university level are always based on what did you do before, and therefore what is the probability that you will do well tomorrow, okay? That's the whole idea. Identifying at-risk students and providing necessary resources. Okay, you have been admitted. Hey, is this student at risk of not graduating on time or failing, whatever, that is an at-risk student. And now that we have admitted the student, we cannot, there is a statistics that you have to keep, data that you have to keep. The graduation rate is what it is called. Graduation rate is of the students that were admitted, how many graduated in a timely manner. Okay, so let's say the typical, it's 4 to 5 years graduation. How many actually, that's the graduation rate. Now, what happens is, if there are many at-risk students, it reduces the graduation rate of that school. Okay, so they have to address at-risk students, bring them at par with the students so they can pass the classes and graduate. So that is critical. So that's how there are algorithms that will actually identify at-risk students. And classification, IT or healthcare. And let's look at that. Classifying emails as spam, that's a decision tree algorithm. We can use classification for it. And there are different classification algorithms as well. Okay, but what I'm saying is, for the same application, you can use more than one algorithm. Classifying by test results for health conditions like diabetes. So yes or no, you look at fasting sugar, you look at HbA1c, you look at triglycerides. These are all the factors that you look at, and then you determine yes or no for the diabetes, or maybe at risk of diabetes, right? The third category. It could be a multi-way split, not just yes or no, but hey, at risk, keep watching, watch what you eat, do exercise, right? So that kind of thing. So this can be used in for different applications, including healthcare. Classifying by symptoms, medical diagnosis, we just talked about that. The chi-square automatic interaction detector, commonly called CHAID, okay, first published in 1980, is a type of decision tree algorithm. All predictors must be categorical or coerced into categorical form. What that means is, now age is continuous, right? But however, we make it categorical, 0 to 10, or 11 to 20, 21 to 30, 31 to 40. So now we are binning. That's what binning is, okay? So we, taking a continuous variable, we actually split it into categories. Uses multi-way splits by default. By default, it's not a binary split. The multi-way split is the default for this one. So particularly useful for exploring relationships in variables and making predictions based on that. It prevents that's the biggest advantage of CHAID. It prevents overfitting right from the start, because split only if there is significant association. So otherwise it's not going to split, which means you avoid overfitting automatically. Okay, so that's one of the biggest advantage. Application used in marketing to identify specific customer segment. So just giving you an application, so that way you can look at this and say, oh, this is a good algorithm for me to use for my research study that I'm doing in whatever. Okay. Iterative dichotomizer 3, ID3, iterates through every unused attribute, calculating information gain for each. Okay. Selecting best attribute to split the data based on information gain. This is called the greedy approach, because it just looks at one record at a time. Okay, one record at a time. This can overfit the training data. So that, which we were trying to, the problem that was addressed previously, this becomes a problem now in ID3. To predict whether to play tennis, so again, a decision tree algorithm for sure, but overfitting can occur. Designed to mimic how the human brain processes it. This is all about AI, right? AI is about, hey, how is a human brain going to process information? Well,
Thank you, madam. Thank you for allowing me to ask multiple questions in a session. Now, in the decision tree, I think we do not have a unique decision tree for the given data set. So we may have the multiple decision trees. So on what criteria we should select the best tree for the given data set among all possible n number of trees? And what is the upper bound of having the decision tree for the given data set?
okay. Very good question again. For any data set, we have to look at if the data itself, let me give you a really small example. Let's say it has 100 records, okay? And we try to split it over 10 different features. That's going to be like overfitting that data. Okay, so we have to look at the size of the data and then we have to determine how many features. So there is no hard and fast rule that you can have only so many or so. We have to look at the data size. We have to look at features that make sense. Again, that's where the issue of when you try to do the clusters, okay, in the decision tree or decision tree even, you're first determining what the different categories are, right? Because without that, you cannot make a decision between 1 and 2. What is 1 and what is 2? So to determine what is 1 and 2, or to determine it should be 1, 2, 3, where it's a multi-way split, okay? Or 1, 2, 3, 4, whatever it is. We have to look at whether that splitting actually is significant enough to merit its own category. Is that making sense to you? I can explain to you later. But basically, the whole idea is how distinct are the two groups. When you say rainy or sunny, rain and sun are different. But if you say, oh, sprinkle and heavy rain, what is sprinkling and what is heavy rain? It's hard to tell. Somebody might say, oh, this is heavy enough. And somebody might from Cherrapunji or, wherever it rains every day, all the time, might say, this rain, this is not called rain. While someplace else, they might say, oh, in Rajasthan, they might say, oh, this is rain, right? So interpretation of data can be different for different people, different categories, different data set. So we have to know what that data set is. That's where our logical analysis comes into play. So do not leave logic at the door and only do mathematical stuff, okay? Bring your logic with you. Bring your experience, human experience with you, okay? Neural networks learn deeply in a very real sense, but under the hood, the algorithms and techniques being deployed are not much different from those found in stats or other data mining algorithms. Other techniques learn from historical examples in the same way. The difference is this one does one record at a time. Neural networks often modify their model one record at a time, while others are more historical examples taken all at once, okay? So key components, input layer, hidden layers, and of course then the output layer. So as you can see, input, then all these hidden layers, which really as even an algorithm designer, we don't see, okay? And then we have the output layer, provides the decision or the prediction. So supervised learning algorithm, convolutional neural networks, I'm giving you examples and we'll look at these in a little more depth. Recursive and recurrent. And unsupervised would be autoencoders, the generative and self-organizing maths. So convolutional neural networks, or CNNs as they're called, extract features from input data progressively, starting with basic features like edges and then identifying more complex patterns. So edges, look at the edges, then come in the middle, which means you're looking at the most obvious first and then coming to the less obvious. That's what the concept is, okay? Convolutional layers apply filters or kernels to the input. Each layer provides an output that highlights detected features or feature map. And process is hierarchical. You look at the top, then the next, so it's hierarchical, okay? Feature learning as data passes through multiple layers. Recursive, on the other hand, deep neural network formed by applying the same set of weights recursively over hierarchical or structured data prediction. Repeatedly, recursive, do it over and over and over and over. That's what recursive is, okay? Inherent tree-like or graph-like structure. Generative, on the other hand, two neural networks pit against each other. This is actually what generative AI is, okay? It actually is based on this algorithm. It's basically you pit ones against the other. You create something and then you say, is this good enough? And then the other one says, no, this is not good enough. Look at this, that kind of thing. You pit against, right, exactly. Generator and discriminator. The discriminator is going to analyze and critique your generator. Then the generator, okay, I'm going to use a bet. That kind of thing. So that tug of war is constantly happening. So the generator creates new data instances or fake data that resemble the training data, which is the real data, right? Because that's what the whole idea is. The discriminator tries to distinguish between real data and the data generated by the generator, which is actually the fake data, and then says how closely can your fake data imitate the real data. That's the whole idea. The whole idea is how close can you come to the real, the generator, which is generating fake data. So the adversarial process and iterative feedback loop improves both, right? Because that's what tug of war is. It increases the strength of both. Okay. Both generator and discriminator. It has two loss functions, but what is the loss function? Loss is the difference between the two distributions, real and fake. That is called the loss function. So we are always trying to minimize the loss, correct? We are always trying to minimize the loss. Transformers rely on the attention mechanism. The model weighs the importance of different parts of input sequence when processing it, which is crucial for understanding the context, say, of a sentence and how different words relate to each other. Like the context of a sentence, the same word can have different meanings in the same, in different contexts, right? Okay. Okay. See, here are the applications. ANNs used in natural language processing. All of, many of you maybe, if you're doing research, have NLP projects. CNNs used for visual data pattern recognition with images and videos, machine translation, chatbots and speech recognition, text generation. That all is recursive neural networks. And the generative are used to generate images based on textual description or AI-generated art. Okay, if you have a startup, generate musical compositions, AI to using musical compositions, images of objects, faces, scenes, right? Fake faces, create synthetic data to augment existing data sets. Face aging. Have you looked at some of those face aging ones? How can you look at 60? Funny. Okay, example. Recognition on handwriting recognition. Okay, so when we look at, there are some handwriting experts that will actually tell you if you're but there's an algorithm now for it. Okay, shortest route, like telling the traveling, be used in delivery. Okay, so Amazon drivers or something where they are driving, or Uber, not Uber, but Uber Eats. Okay, so if you are delivering something, then what is the best, how to route, okay, most efficiently? That's what traveling salesman is a common problem right from like decades ago. Okay. Information compression, image compression, we always want to, when we send something, we always want to minimize the bandwidth usage, right? But it has to be accurate enough. So all the information has to be there. Prediction stock exchange, that's, what are the stocks going to do? So wrap up and takeaways. I know we are just like 2 minutes over the hour, so just bear with me. And analytics is the use of data, statistical analysis, and explanatory or predictive models to get insight into complex issues in business and government. Of different applications of machine learning algorithms include, but are not limited to, healthcare, intended to improve health services, and everything we try to do is to improve the existing whatever infrastructure. Teaching and learning, intended to enhance student learning and teacher effectiveness. Business and industry for decisions to automate and optimize business processes. Government and services, because government is all about providing services to the citizens, right? Ensure national safety and security. So Thank you. So I presume we are going to take a short break and come back for the next lecture, but it will be a really short break. There's a question. Absolutely, you can combine more than one algorithm. Absolutely. And decision tree, and what was the other one you said? But yes, the answer is you.
Clustering, decision tree and clustering. Like the root node is a decision tree. Then we put clusters in internal nodes and leaf nodes.
Yes.
Can I do that?
Yes, you can definitely combine two algorithms. You have to decide which one you want to run first and which one you want to run next. You cannot, they are not run in parallel, like, or both at the same time. You have to run first, and there's a rationale for that. You have to develop the rationale. Which one do I run first, and then which I run next? Okay, but yes, the answer is yes.
My question is with the CNN algorithm. CNN. Okay, with the expect the features automatically, right? Now, let me give you an example of a lung disease detection using CNN. Wherein we have the X-ray of the TB patient and X-ray of the COPD patient. So I think maybe the image is nothing but grayscale. I mean, black and white image for the TB patient and as well as for the COPD patient. Now, when it comes to the CNN, it extracts the figures automatically. So from the black and white image, what could be the features for the TB patient and what would be the features for the COPD patients? Because ultimately, I couldn't understand even the last week asked features and he expected the use from the image.
I will share with you a research study which we did in China. Actually, it was on biometrics, and I'll talk about it is very similar. It was thermal imaging, and so thermal imaging, it was the how much the color. How red was it, how orange was it, how yellow was it, all those colors. So in black and white, I would say it would be shades of gray, how dark, how light, and then you determine which structure. So that would be the feature, and then those features would be the how deep that color is.
When you consider only the dark and white wave, then suppose the patient comes with a pneumonia disease. Now, it may happen that they categorize it as a TB or COPD rather than the pneumonia patient. So, false positives would be increased. This is just my understanding that if you only put grayscale, yeah, focusing on white pixels, gray pixels, and the range is only gray pixels. But gray, from my perspective, gray it when we talk about RGB, it goes from 0 to 255. But when we talk about gray, it should be the half of this range. So, this his word.
Okay. I would say we should not just depend only on the image, because there are many, many other symptoms that need to be considered, and the physicians would be aware of what are the typical symptoms for COPD versus, tuberculosis or something like that, pneumonia. And then they would take the image as only one of the data point, and then there will be several other data points that they might be considering about the weight or weight of the person, how quickly the weight loss happens or does not happen, whatever that may be. And I think there is much more that goes into it than just the image. The image is only one symptom or one data point that the physician would consider. So I don't think we need to focus so much on just one and then say, oh, what about this? I think it's a more comprehensive picture that the physician would take. I mean, I'm no physician, but that's what I would think. And we will come back, okay, folks?